Hello everybody, this is part 2 of the video series where we're learning how to do descriptive statistics in R. In this particular video, we're actually going to do some basic analysis on a data set that is already built into R. So let's get started. So I've opened a new R script file and I've called it part 2, descriptive statistics using built-in data sets in R. And as always, it's a good practice to set your working directory first, so that's what I'm going to do. And now what I actually want to do is, if you notice in my data environment, you'll see that these are all objects that we generated in part 1 of our video series. So I just want to have a very clean environment before I begin. So I'm just going to do that. But before that, let me show you a different function that R has. The function is called ls. Open and close bracket, don't put anything into the bracket. Now, just run that, and you'll see that in the console, R actually shows you the list of all objects that are currently in the environment. So, okay, so this is pretty far down in the console. So what I'm going to do is I'm going to clean up the console. So there's a bloom type of icon here on the console page, on the console window. So if I click on that, it will clear my console and I have a clean place to work on. So let me show you the list command now. So there we go. So it shows the list of all objects in my environment. Now I'm going to write a code, write a line which will actually remove all of these objects from my environment. And that's the function remove. It's called rm, open brackets. And within the bracket, I'm going to say list equals ls, open and close brackets. So this command actually tells R that I want to remove the list of all objects that are in my environment. So that's what list equal ls plain brackets does that. So let me run this, and there you go. My environment is now empty, and I have a clean slate. So which is great. You may not always want to do this, but for this example, I just wanted to show you how to use that code. Sometimes you may have different data sets that you work on in different R scripts, and you may want all of them in your environment to do some joint analysis together. So in which case, you should not remove all the objects from the environment. But this is a cool trick to know, so there you go. All right, so now let's see how we can load this data set that we want to analyze. So before that, to get a sense of the different data sets that are pre-built into R, type the word data, open and close brackets, and just press enter. Control enter. Now this gives you a page which lists the different data sets that are pre-built into R. There are quite a few, which is pretty useful to try your hands on and practice some data analysis skills. So we're actually going to use this data set called iris, which has data about flowers, their petal lengths, and so on. So to load the iris data set into R, all I have to do is type the word data, open and close brackets. Now you see the minute I do that, there's this drop-down list that opens up in R, listing all the data sets that are pre-built into R. I can either choose iris and click on this, or I can just type iris and do Control Enter. The data set is now loaded into R, and it shows up here in my environment. Now, to see what is there in this data set, what I'm going to do is I'm just going to type view iris and Control Enter. There we go. So this opens up another tab, which actually shows you the data set. So the data has about 150 entries in 5 total columns. So there are 4 variables, 5. Sepal length, sepal width, petal length and petal width, and the species. So this looks quite a bit, you can scroll down and you can see that this is pretty much like a spreadsheet. And there are about 150 observations in this data set. And that information is also available here in the environment. It says 150 observations, 5 variables. I can close this now. So let me get comfortable with this particular data set. So to get the first thing that you want to do is just say str, which is short form for structure of iris, Control Enter, and look at what shows up in your console. It's a data frame. So this is so data frame is a type of object in R which stores data sets. So you ideally, for your analysis, we mostly want our data to be in the structured data frame. There are 5 different variables. The sepal and the petal related variables all have this indicator called num, which tells us these are all numeric variables or quantitative variables. And then I have species, which is listed as a factor variable. Factor variable is actually nothing but a categorical variable. So this is a factor variable with 3 levels, meaning it's a categorical variable with 3 categories, which are the species of the flowers. Now, there's a reason why R calls this a factor variable, and we'll come to that in a later video. So for now, it is sufficient to know that we have 4 numerical variables and 1 qualitative or categorical variable. So that's the structure. Now, notice how that every variable, preceding a variable is this dollar symbol. That's going to actually come in, it'll come into play in just a second when we start doing some analysis on this data. So just make a note of that. Okay, so how else can we explore this data set? So there's a command in R which actually helps you see the first 6 rows of the data set, and that's called head. So I want to see the head of iris, and when I run it, it shows me it just shows me a snippet of the data set, just the first 6 rows. If I want to look at the last 6 rows, I do tail of iris, and I run that. It shows me the last 6 rows from 145 to 150. Then if I want to view the data, I type view iris. Notice that V has a capital uppercase V. Generally, commands in R are case sensitive, so you want to make sure you write the command correctly. So when you view the data set, it opens up in a different tab, and you can scroll down and check how your data are organized. So we'll come back to this. If I want to learn if the number of rows in this data set, suppose if it's too big to scroll down, of course, you can always get the number of rows and columns from here, but if you want to use it in some calculation, you can do n row of iris. It will tell you the number of rows, 150. If you want to get the number of columns, you type n col of iris. It gives you the number of columns, which are 5. If I want to look at the dimension of this data set, which is actually number of rows and columns, there's an easier command to do that, which is dim, or which is short for dimension. So I want to find the dimensions of iris. Press Control Enter. You'll get 150 and 5. So the first entry will always correspond to the rows, number of rows. The second entry will show you the number of columns. So there we go. We have 5 rows and 150 rows and 5 columns. So I'm going to periodically keep saving my R script so that I don't lose any data or any information that I've typed in there. So, okay, so I think we are now, we've done some basic exploration of the data set. Now let's start doing some analysis. So there's a very neat command in R which actually helps you see the summary statistics for all variables that are in the data set, and that's called the summary function. So you say summary, open and close brackets, and within that you type the name of the data set and do Control Enter. Now notice what shows up in your console. So I have a summary of every single variable. So sepal length, sepal width, petal length, petal width, and species. For the first 4 variables, these are all numerical variables. And for each of them, R gives me the minimum value, the first quartile, the median, the mean, third quartile, and the maximum value of that variable. So these are all the summary measures that we're typically interested in. And R gives us the summary statistics for every single variable in the data set. So for all numerical variables, you have all of these measures of central tendency and measures of relative position indicated. Remember that species was actually a factor variable or a categorical variable. So we can't compute mean, median, and other such things for a categorical variable. So instead, R actually tells us the frequency of the different categories. So Setosa is a frequency, is a species that repeats 50 times, meaning 50 rows of the data pertain to this species of Setosa, 50 rows for versicolor and 50 rows for Virginica. And if you want to quickly actually check if that is indeed the case, you can go and open the data set. So for that, what I have to do is I just have to view data, view iris, press enter, and there you go. So I have Setosa, and from row 51, I should see something else. There we go. I see versicolor, and then from row 101, I should see the third species. There we go, Virginica. So that's what the frequency tab tells us. So it's a pretty nice command to figure out the summary statistics. Now, if we want to focus on a particular variable, then we can actually apply this summary function to a single variable. Now make a note of how I actually refer to a single variable. I'm going to call it summary of, let's say I want to analyze this variable petal length. If I just type petal.length, that's how the variable is named here. So I'm just going to use the same name. If I type summary petal.length and if I do control enter, R shows me an error that it can't find the object petal.length. So the way to get around this is you always have to prefix a particular variable with a dollar symbol, and you have to prefix that dollar symbol with the particular data set from which the variable is available. So I will write this down as summary. The source data set is iris, and from there I want to find the variable petal length. So notice how after I typed out the data set's name and I put the dollar symbol, there's this drop-down list that shows up. So I can just click on petal length, or I can type down petal.length. So I click it, and then I now do control enter, and now R runs the command. So I can see the summary statistics for this particular variable. Gives me the minimum, first quartile, median, mean, third quartile, and max values. So it's pretty handy to get all of them at once. I can also find, there are also functions to individually calculate all of these. So to find the mean for a particular variable, I type, the function is just mean. I type mean of iris petal length. I get the answer, 3.758. The function to find median is just median, iris petal length. It gives me 4.35. So R actually doesn't have a built-in mode function because mode can be computed for both quantitative and qualitative variables. So it requires some bit of extra programming. So we can skip that for now. Let's find the minimum value. And to find the minimum value, the function is actually just min of iris petal length. We get the minimum value. If I want to find the maximum value, the function is just max. Iris petal length. I get the maximum value of 6.9. And to find the range, R doesn't, I'm not sure if R has a range function, but you can actually quite easily do the max minus min. So you can use the functions itself to do that. So I want to find the maximum value of iris petal length minus the minimum value of iris petal length. Enter. It gives me the answer as 5.9. So it's already doing calculations with the placeholders that I'm feeding it. Now, if I want to find the quartiles, then the function to do that in R is actually called quantile. So that's the function. Now, R actually has this one single function, which actually computes whatever you want it to, different measures of relative position. So for instance, this function can tell me the various percentiles, it can give me the different deciles, it can give me quartiles, it can give me the median, anything. So quantile is essentially when you divide your data set into different equal parts, every part is a quantile. So percentile is an example of a quantile where every part accounts for 1/100th of the total. Quintile is an example of a quartile where every part accounts for 20% of the total. Quartile is a type of quantile. Every part is 25%. Median is a type of a quantile where every part is 50% of the data and so on. So to get the quartile, we use the same quantile function. So the way we do it is you type quantile, open brackets, tell which variable you want the quantile, comma, you indicate the specific number associated with that position. So you could either think of the area being divided into say 100 shares where every part accounts for 1%, or you could, instead of thinking about it as percentages, you could think of it as proportions from 0 to 1. So the 25th quartile, the first quartile or the 25th percentile is given by the number 0.25. When the numbers go from 0 to 1, 0.25 accounts for the first quartile, which is nothing but your 25th percentile. So I type 0.25 here, I do control enter, it gives me the answer for the first quartile. So if I want the third quartile, I'm just going to copy this and I paste it here. Third quartile is nothing but the 75th percentile, which I'll indicate as 0.75. I get the answer 5.1, which corresponds to the numbers that we saw here, right? First quartile is 1.6, third quartile is 5.1, and that's precisely what we've been getting. So our answers are correct. So suppose I want to get different quartiles in one go, I can use this quantile function. Quantile for iris petal length. Suppose I want the series of say first, second, and third quartiles. I'm going to put this within a list. So whenever you want to create a list in R, you always use the concatenate command, which is just C in brackets. That's the way to create a list. So within these brackets immediately following C, I'm going to put in my list of different numbers that I want. So I want the first quartile, I want the second quartile, and I want the third quartile. So I'll do this, control enter, there you go. So it gives me all three numbers that are of interest to me. So these are some quick functions that we use to get some summary statistics in R. Now if you notice, we always put this data set name and then a $sign and then type the variable name. One way to get around that is to actually tell R that you want to attach this data set to the stream of operations, so that you don't want to keep telling R that every time go to this data set, recognize this variable and use it in the analysis. Instead, you're just telling R, I'm going to attach this data frame to the environment, to our working file, and therefore whatever variable I'm referring to just comes from that data set. So to do that, so suppose I want to find the mean of just petal length, okay, or it'll show me an error now. But if I attach iris, okay, I run this, and now if I run the same command again, it'll give me the mean of petal length. So it means that it's attached iris to the R working space, and it's just figuring out that petal length comes from iris already. If I want to undo this, then the command is detach iris. Now, if I still type the same thing, it will now show me an error, meaning I can now compute mean only when I do iris dollar before that, and it gives me the answer. So those are some quick summary statistics. Now we're going to generate about 3 different plots. So we saw this basic summary number, right? So let's analyze petal length itself. So if I summarized the variable iris petal length. So we have all of the values of interest to us. Now let's put this all in a box plot. So the command to do that is actually just box plot. So to learn what box plot is, I've just typed a question mark followed by box plot. If I run this command, R will open up a help file here in the lower right hand corner, and it will give you a sense of the different arguments in that particular function and what each argument refers to. So argument into a function is pretty much like the different inputs that you need in a given function. in order to turn out a particular output of interest. So for a graph, input will be the particular variable that you want to be graphed. And along with the main variable of interest, you may want to specify other things like what is the name for the x-axis, what is the name for the y-axis, name for the title of the graph. All of those are actually inputs into the main graphing function. And the technical term for that is called arguments. So that's what's given here. So it gives you a list of various commonly used arguments. And at the end of the help file, you'll see some examples which actually give you the code. So, so you can check it out later and see, play around with some of these examples. So now let me type in the simplest version of the box plot code. So suppose I want to do a box plot for just petal length. I'm going to type box plot iris $petal length and let me run this. When I run it, you see that in the plots tab of this lower right-hand corner, there's a box plot which shows up, which essentially captures all of the numbers of interest. So minimum value is 1, first quartile is this end of the box, this is the median, this is the third quartile, and this is the maximum value. There are no outliers here, and therefore this is our box plot. So let me add some color and flavor to this box plot. So let me say, so to add a particular input, all you have to do is you put a comma, you add the next argument, put a comma, do the next argument, and so on. So I'm going to just copy this base command, put it here. Now I'm going to put a comma after the first argument, and I'm going to type the next argument, which is just color. I can write that down as COL equals, let's say, blue. So I type in the color within double brackets because that is the R syntax. Now I do command enter. You see that it's changed in color. Now let me add a title to the box plot. So let's say, so the argument for title is the word main. So instead of putting it all on the same line, what I'm just going to do is I'm just going to press enter now. And I'm going to type it here. And R will automatically understand that this is one single line of code and run it together. So you don't have to worry about it. So the title is actually box plot of petal length. Okay. Title also needs to go within double quotes. Now my cursor is here, but if I just click Control Enter, R will still run it, identify it's a single line of code and run it. So there we go, it's run it and the title shows up. Now let me add a label for the x-axis. So maybe I don't need a label for the x-axis because there's just one box plot. Suppose I want to look at two box plots. So suppose I want to look at box plot of petal length and say sepal length. Okay. So essentially what I do is I put a comma and write down the other variable's name as well. So box plot will run, the command will create a box plot for each of the variables listed here. And now I'm going to choose the color, but I have two boxes to know color. So I'm going to put the colors in a list. So I'm going to say color is, say the first one can be blue and the second one can be red. Okay. So I choose the color, then I've given the same title. So now let me run this. There you go. So, oh, I should fix the title. It should be box plot of petal length and sepal length. Okay. The title is changed. Now suppose I want to indicate what this plot is for and what that plot is for. I can actually add that as another argument. So I'm going to call that argument is names. So I'm going to say names, again going in a list. The first one is petal length, all within double quotes. Then the second one is sepal length. And this, and it shows you things here, petal length and sepal length. Now, if I want this to be a horizontal box plot, all I have to do is just type in one more argument, which is horizontal. equals true. Run this, which just becomes a horizontal. Now you can go in and save this plot by looking at this export button here, and if you click on it and you want to save it as an image, you can save it and give it any name that you want. Press save. Now I'm just going to, I don't want to save it right now, so I'll just cancel this. So that's how you generate a box plot. Now the next thing I want to show you is how to draw a histogram. So the command for that is just hist. So you can check out the help file here for histogram. Now let's draw a histogram for the same variable. We'll draw it for a different variable, sepal length. So command for that is hist, iris sepal length. Okay, let me run this. There you go. So you have a nice histogram with the title. It is showing me the frequency of observations here. And it seems to have automatically taken intervals from 4 to 4.5, 4.5 to 5, and so on up to 8. It has an x-axis value, which is pretty good. Now, what else can I do to this? Let me add a color. So, comma, color equals, say, violet. There we go. So we've added color now. Let me add a title. So, comma, main histogram of sepal length. Okay. There we go. So we have a title. Now let me edit the x-axis name because it looks a little unprofessional to say iris $this. Everybody will know that you've done it in R. So let me edit this. So I'm going to put a comma. The function, the argument to change the label to the x-axis is just xlab, x label shortened to xlab. I'm just going to call it sepal length. Okay, close this. Now, right. So it's giving me a pretty neat x-axis label. Now, suppose I'm not very happy with these breaks, but I rather want them. So I have about how many bits? 1, 2, 3, 4, 5, 6, 7, 8. Suppose I don't want as many bins, but rather I just want fewer bins. Then the argument to do that is called breaks. So breaks tells you the number of bins you would want to have. So it's called breaks. So suppose I say 4 and I run this. Then the histogram is plotted with just 4 bins, 4 to 5, 5 to 6, 6 to 7, and 7 to 8. And suppose I want to say 2 breaks, 2 bins, then I just type break is equal to 2, run it, just 2 bins. So if I want 6, I can do 6, I want to do 8, and then it gives me 8 bins. Now, there are a few other things we could do as well. So this goes from 4 to 4.5, 4.5 to 5.5, and so on. If I want it to be finer, I can actually type out this break, specify the bins in terms of a finer measure. So I can say I want the breaks going from, say, I can use the sequence function here. So I want the breaks to be numbers that go from, say, 4 to 8 in increments of, say, 0.4. Okay, so let me run this and you see how the shape of the histogram changes after that. So this is 4 to 4.8, 4.8, 4 to 4.4, 4.4 to 4.8, 4.8 to 5.2, and so on, and it goes on up to 8. Suppose I want even finer bins, which go from 4 to 8, but in intervals of 0.2. Let me run this. So I have an even finer distribution. And I can make it even finer by saying 0.1 and running it. But then the issue is that after a while, if it's too fine, it may become unwieldy to understand what is happening. So we may just want to stick to our initial thing that R automatically gave us, which is going from 4 to 8 in increments of 0.5, which is our initial graph. So these are different ways in which you can play around in the histogram function. And the last chart that I want to show you today is just a simple scatter plot. So the command for that is just plot. So if you look at the help file, it shows you a couple of these answers, results. So click on the generic XY plotting, and that will tell you the different arguments. So generally, the first variable that you put into your plot function will be the x-axis, and the second one will be the variable in the y-axis. So if I want to plot, say, sepal length in x-axis and petal length in y-axis, I just do iris sepal length, comma, iris petal length. Run this. Voila, you have a simple scatter plot. Now I can do the same adjustments to this. I can say, X slab is now sepal length. Then I can type Y lab, which is Y label, is petal length. And then main is scatter plot of sepal length and petal length. And I can run this. There you go. So you have everything very neatly done here. So check out the help file for the plot function because it tells you that you can use different symbols. So here you have hollow circles, you can have triangles, you can have squares, and there are arguments to edit that. You can change the color of these dots, and then you can have different colored dots for different species of flowers. So we have 3 species of flowers. So I can make the first species blue, second one green, third one red, whatever I want. So all of those options are all possible. So you can check out the plot help command, and I'll also share more resources to help you out. So that brings me to the conclusion of this very long demonstration video. Hopefully you find it helpful. So I'll see you in another one.